You know, when most people think about progress in AI, they think about bigger, more powerful models. But in high stakes fields like healthcare, that's not just a misconception, it's actually a dangerous one. In a clinical setting, there's only one way for an AI to get truly smarter. It has to learn directly from the experts who are correcting it. Today, we're going to pull back the curtain and show you exactly why that is. Okay, so here's how we're going to break this down. First, we'll talk about a hidden threat in clinical AI. Then, we'll look at how to capture that critical expert feedback. After that, we'll see how that feedback gets engineered back into the model, and then walk through the safety gates it has to pass. And finally, we'll zoom out to a big picture governance framework that builds trust right into the system's DNA. All right, first up, let's really dig into a major flaw and how we usually measure AI performance. Because in a hospital, your standard metrics aren't just missing the point, they can be actively harmful. When you see a number like 95% accuracy, what do you think? Pretty good, right? An A? But in medicine, that last 5% isn't an acceptable error margin. It's a massive systemic risk. Every single one of those errors is a potential patient safety issue, a tiny crack in the foundation of trust, a moment where the system is failing someone. And this leads to this quiet, corrosive problem that we call digital biofilm. Think about it. It's the slow, subtle buildup of AI suggestions that sound right, that look plausible, but are just flat out wrong. And over time, this biofilm gums up the works, increases the mental burden on clinicians, and just steadily erodes trust in the whole system. Which brings us to the absolute heart of the matter. If your AI doesn't have a built-in way to learn from an expert telling it no, that's wrong, then it's fundamentally broken. It's not actually getting smarter. It's just repeating the same mistakes with more and more confidence. It's getting louder, not better. So, how do we fix this? Well, it all starts with a change in mindset. Real lasting trust isn't built when an AI gets something right. It's forged in how the entire system responds when the AI gets something wrong. This is where the human expert isn't just a user, they're the most valuable part of the entire loop. The key to this is a mechanism called the triple store. Look, we don't just log that an error happened. That's totally useless. Instead, we capture three critical things all at once. What was the original context the AI saw? What was the specific bad answer it gave? And, most importantly, what was the clinician's better, corrected action? This bundle is the pure raw material for real improvement. And this part is crucial. It has to be completely frictionless for the clinician. These are busy people. They don't have time for a pop-up survey. A simple one-click menu lets them instantly tag why it was wrong. Was it an incorrect dose? Did it miss a key lab result? That one single click turns a simple nope into structured, clean, high-value data, perfectly teed up for the next engineering cycle. Okay, so what happens next? We've just captured this perfect, expert-validated data point straight from the front lines. Now, let's go behind the scenes and see how that one moment of rejection gets transformed into a smarter, safer algorithm. This is where the magic happens. The first step is all about transformation. We take that raw data from the triple store, the context, the mistake, and the fix, and we reformat it into something the model can actually understand, an instruction response pair. It's like creating the perfect flashcard for the AI to study from. Then, we use this really powerful technique called direct preference optimization, or DPO. Here's the cool part. Instead of just showing the model the right answer, we show it both its original mistake, the losing completion, and the expert's correction, the winning completion. We're not just teaching the model what to say, we are explicitly teaching it what to avoid. This is how you directly attack and remove that digital biofilm. Now, you don't do this with a sledgehammer. You do it with a scalpel. Instead of a massive, expensive, and frankly risky retraining of the whole AI, we use something called LoRa adapters. Think of the main AI model as a huge, comprehensive medical textbook. A LoRa adapter is like a tiny, peer-reviewed sticky note you add to one specific page. It updates the information on, say, kidney-related dosing without messing with the rest of the book. It's surgical, it's precise. So we have an improved model. Great, we're done, right? Not even close. In healthcare, an improvement is totally meaningless until it's been proven to be safe. So before this new version can ever even get near a patient decision, it has to pass this intense, automated gauntlet of checks and balances. And the most important test in that gauntlet is what we call shadow mode. The new, updated model runs silently in the background. It sees live data, it makes its predictions, but nobody sees them. Then we look back. And if we can prove that this new model would have cut down the number of times clinicians rejected its advice by a lot, say more than 30%, only then is it even considered for promotion into the live system. And this image here really visualizes the whole process. It's not a one-time trek, it's a continuous loop. You see how it flows from data hygiene on the left, through development, into the live workflow. And then, crucially, it feeds right back into the monitoring and feedback stage on the right. The entire system is built for constant, safe improvement. At the very heart of this is something called the admissibility matrix. This is basically the rulebook that defines how much power the AI has, based on the clinical risk. For low-risk stuff like scheduling, sure, it can be autonomous. For medium-risk things like drafting notes, it can be assistive. It drafts, a human signs off. But as the risk climbs, the AI's authority gets dialed way back, making sure it never, ever operates outside of its designated safe zone.
Okay, let's zoom all the way out now and put all these pieces together into a really clear strategic framework. This is how leaders can actually build trust into their AI systems from day one. Not with a policy document, but with safeguards built right into the code.
Gate number 1 is information hygiene. From a leadership perspective, this is your first and most important line of defense against risk. An AI that's fed polluted or incomplete data isn't just going to be inaccurate, it's a huge liability. This gate ensures everything is built on a sterile foundation, protecting the whole system from being corrupted from the start. Gate 2 is the logic scaffold. This is all about making your AI defensible and auditable. Look, when a decision is questioned, you can't just throw up your hands and say, the AI did it. This gate demands that every single recommendation can be explained and traced back to a specific model and a specific clinical guideline. It turns the dreaded black box into a glass box. Third is workflow admissibility, and honestly, this is the key to getting people to actually use the thing. This gate answers one simple, brutal question. Does this tool actually help a busy clinician, or is it just more noise, another click? If the AI just adds to their mental burden, it's going to be ignored, and that whole investment is worthless. Admissibility here is really a stand-in for utility. And finally, Gate 4 is the eligibility matrix. This is the ultimate check and balance. This is the hard-coded safety protocol. It defines the AI's ethical and, frankly, legal right to take an action, making sure its autonomy never outpaces the clinical risk. This isn't a suggestion, it's a hard-coded brake on the system's ability to act. So, the huge takeaway here is this. AI in healthcare is not about replacing brilliant clinicians. It's about building what we call cognitive scaffolding, smart systems that help reduce the mental load, that keep a clear audit trail, and that manage risk, which frees up experts to focus on what only they can do. And all of this leaves us with one final critical question for anyone building or buying these systems. Is your AI governance a policy document that's collecting dust in a binder somewhere? Or is it a living, breathing, automated part of your system's actual architecture? Because in healthcare, that distinction is absolutely everything.